So how is this useful? It's useful in a variety of ways, but the most obvious way that it's useful is in color photography, or the most straightforward way. And in this case, what we have instead of just uh, film with silver oxides on it is we have three layers: a magenta layer, a red layer, or a cyan layer, and a yellow layer. And when white light comes in, or when the light of my image comes in, it reacts with some of these filters. So if I have, let's say, um, we'll say a red house, right, and I have a blue flower next to it. And why not? We'll put a yellow sun up here. All right. Well, the red light reacts with the magenta and yellow filter. So I'm left with the complement of red, which is cyan. And I end up with a cyan house. All right. My yellow sun react with the yellow layer, so I'm left with blue or magenta and cyan. So magenta is magenta plus cyan gives me, if I go back here and think about it, so magenta plus cyan gave me blue. So I have a blue sun. And blue reacts with the uh, gives me its complement. Blue's complement is yellow. So I have a yellow flower. All right. And this is the color negative. And it goes through a variety of processes, but and then everywhere I had white, I would actually have black. So I'd have black here and black here. So white becomes black, yellow, blue, red, cyan, blue, yellow, green would be magenta. And this is the negative, color negative image. That color negative image is then, after the developing process, is then printed, and I end up with the color positive image. So when I take the picture, the film reacts with these color subtracting primary colors to produce a negative image. And then the negative image is printed on paper, special paper that takes those negative images and again reacts with that to produce the positive. So I go from color positive to color negative when I take the picture, and then color negative to color positive after the development process is finished. And that requires a variety of steps, including developing and washing and bleaching and stabilizing. And all of those aspects are gone through in some detail in your book. So make sure you take a look at that. The next area that this is used is pigments. So when I think about something like a leaf or paints, I don't have color filters happening, but what I have is absorption and scattering. So if I have a green leaf, right? So here's my green leaf. What's going on here is white light's coming in, and that means I've got green, blue, and red light coming in. So green, blue, and red. The blue and red are absorbed, and what's reflected is the green. So I have the blue and red light absorbed, and the yellow and the green light reflected. And similarly, if I mix pigments uh, in paints, I can come up with a bunch of different colors, and that process is subtractive. So that means if I mix a bunch of colors together, I get black. And I can use the ideas of filters and pigments to change, say, the hue or the saturation of the color. So if I take yellow paint and I mix it with green paint, that should give me what color? So if I take blue and yellow paint, I should get black. But in fact, I don't. I get green. So why does blue plus yellow give me green? Well, that's because these ideas of things being as simple as red, blue, and green isn't always 100% true, right? This is a simplification of an infinite spectrum. And the filters and the pigments in our eyes aren't really this simple. So the red filter might filter in red, but also some blue, right? And when I take yellow and uh, blue and yellow paints, um, the blue paint absorbs red and green, but not perfectly. So it might look something like this. And the yellow absorbs blue and green, but not perfectly. So it might look something like this. And I have this little bit of overlap here where it's above, and it's above in the green area. So anytime I think through color subtraction that I should get black, I always want to double check and see, is this simplification of red, blue, and green, or cyan, magenta, and yellow, uh, adequate for our uh, actual application? And the answer is sometimes no, sometimes yes. And the last thing we want to think about is filters in terms of changing hue and saturation. So if I have incoming light that's, let's say, unsaturated blue. So unsaturated blue has blue with some red and green in it. And this is low brightness unsaturated blue. And I stick it in a filter that is blue green. So it's closer to blue than green, so it's not yellow, but it's blue green. My final result is low brightness, but not unsaturated blue green. So it's moved it toward the blue side, so it's made it more blue than green, and it's removed the red, which is why we had an unsaturated blue here. So as long as one of these values is 0, I'm not adding white to my color. So I've taken my unsaturated blue and turned it into low brightness blue-green that is saturated. Now, one of the things that can happen here with filters that isn't true with paints is if I take something like, let's say, we can even do something as simple as white light. So let's say I've got R, B, and G, and I've got white light, so 1, 1, and 1, and I've got a filter that, let's say, is we'll say it is a purpley, right? So a purpley would be red and some blue, so purple red, and no green. And I put it through this filter. I get 1, 0.5, and 0. So I end up with a sort of purpley red. And if I put it through the same filter again, now I end up with 1, 0.25, and 0. So I've taken white light, put it through a purpley red filter, uh, and I've ended up with an even redder light. And that's because of the way transmission works. So this doesn't work with pigments, but it does with filters. So if I put two of the same filters in front of white light, it actually does change the hue of the color I'm talking about. So filters can remove saturation or change the hue of light that it comes in contact with. So thank you so much, guys. And if you have any questions, don't hesitate to email me, and I will see you guys soon. All right. Bye-bye.